Today during our lesson, we're going to be learning about social media and social networking, how it works, how it happens, etc. So the question at the end of the day you need to answer is, do social networks make us more connected? And I want you to really think about this. Do you think you're more connected with people through social networks? So the first thing we're going to look at here, watch this video. And I want you to think during this video, what do you think is the ultimate purpose of social network? So we're going to watch this cool little commercial.
Chairs. Chairs are made so that people can sit down and take a break. Anyone can sit on a chair, and if the chair is large enough, they can sit down together and tell jokes, or make up stories, or just listen. Chairs are for people, and that is why chairs are like Facebook. Doorbells, airplanes, bridges. These are things people use to get together, so they can open up and connect about ideas and music and other things that people share. Dance floors, basketball. A great nation. A great nation is something people build so they can have a place where they belong. The universe. It is vast and dark and makes us wonder if we are alone. So maybe the reason we make all of these things is to remind ourselves that we are not.
So what did you notice? What was going on during the video going through your brain? Okay, so if you look at your first question here on your note sheet, networks like telephone systems, Skype, Facebook, etc. depend on lots of users. More users there are, the more vibrant the network can be. The diagram below shows the network as it grows from 1 user to 6. For each step, we're going to determine the total of number of possible connections that can be made between users. So if this is just me, I'm just chilling, I have no friends, and one person comes. That's a connection. So on your note sheet, just like over here, what I'm going to do is I'm going to draw a line. When there's no connection, when there's 1 user, it says down here there's 0 connections. For 2 users, there's 1 connection. There's only just me and that one person. Okay, let's add a 3rd person in here. How many lines or connections do we have? We have 3. I can talk to Sally, Sally can talk to Bob, and Bob can talk to Sally, and I can talk to Bob. That would be 3 different connections. So for that, we're going to write 3. Now if I have 4 connections, if I throw another person in the mix, now there's 1, 2, 3, 4, 5, 6 different connections going on. Everybody can talk to everybody else, right? So if I have 4 users, there's 6 connections. Can you predict how many would be for 5? Well, let's see. So if I had another user in there, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 connections. So just like this, you can draw a star and then connect all the outer sides. So everybody's talking to everybody. Everybody has a chance to talk to everybody. So 6 here. If I had 6 connections, what do you think it's going to be? Well, let's see. It's going to be 15 connections. Can you see kind of a pattern on what's going on? And so if I have a +2, and then 3 to 6 would be +3. And 6 to 10 would be +4. Even though it's not increasing by the same amount, do you see a pattern that's going on here? All right. So it says, without drawing anything, explain how you could could determine the total number of connections in network with 10 users. So how do you think, if I have 10 users, I need to figure out how many connections there would be? So I want you to pause here and I want you to try to figure out what that would be. So there's a couple of ways that you can go about this. What you could do is I could continue to go, right? So I add plus 6 would be to 7, and then plus 8 to that number would be 9, and then plus 9 would get me to 10, right? So I would basically be adding 1 plus 2 plus 3 plus 4 all the way to plus 10. And that number you would get 45. So just like here, I'm going to go up all the way to 10 here. And I can see that I'd have 45 users. 45 connections. Now it says, what about 20 users? Well, I could do the same thing. I could add 1 plus 2 plus 3 all the way to 20. But honestly, who has time for that? Because look, the third one says 100 users. Do you think you're really going to sit here and do that? No, I don't think. I know that I won't. But one way that you can look at it like this in order to figure out your numbers. So I'm sorry, 20 users is going to be 190 connections. So there's a way that we can figure this out. What I can do, especially for 100 users, what I could do is, I know I have 100 users. I'm actually going to multiply that by the previous number. The reason I'm going to multiply it is because I know that Jimmy connected with Billy through Mabel, through Piper, through everybody, and eventually would have 100 people all connected together. So I need to take the previous number before it multiply it. Now, that's a really large number. That number would be 9,900. So this number is extremely large, and it doesn't seem realistic with the number of users that we have. So what actually happened here, this number is really large because I still need to divide it by 2. I need to cut it in half. The reason why is because Billy is already connected on Facebook with Sally. When I go to Sally's friends, I was marking that Billy was also her friend. So I was basically double counting all of my connections. So that's why I need to divide it by 2, because, you know, Billy is already connected to Sally and I can't count Sally connected to Billy because they're already friends. So when I divide this by 2, my actual answer is going to be 4,950 connections. So if I enter here, let's see if I can do it. If I go all the way up and I just keep going and going and going, as you can see, it gets super high and super far. And our little user ball is so congested and combined together. And we finally get to 100. So we have 4,950 connections. So moving on to our second question here. Our third question here now. We're going to write an equation for the number of possible connections for n users and graph it. So as you can see here, we really don't have any users. So if I add a user, I have 2 users and 1 connection because they're friends, and it just keeps going, skyrocketing. So as we get more users and as more people join Facebook, Instagram, Snapchat, you name it, we're going to have more connections than ever. Okay, so I want you to graph this line here. And how it's going to look is something like this. It's going to go all the way up. And remember, it's not quite going to hit the corner there of 500 users because we don't have 5,000 users. So that's what your graph's going to look like. It looks like a big old jumbled mess, doesn't it? So now we're going to look at question number 4, Act 2, Strength in Numbers. So in 2004, when most of you were born, Mark Zuckerberg, launched Facebook from his own dorm room in Harvard. I bet you've heard about this story. But today, more than only 1 in 4 humans are still using Facebook each month. So it's really low. Back then, it was super popular. Now it's not that popular. So the following graph shows how the number of Facebook users has grown over time. So as you can see, in 2004, he had less than 1 million. In 2005, it went to about 5.5 million, and as it increased over time, it started gaining popularity. If you can remember back when you guys were probably younger and goes, who uses Facebook? That's pretty much what our generation growing up was. We made fun of people who didn't use MySpace, but now we have Facebook, so I digress. So what you're going to do now is you're going to pause the video and you're going to actually answer question A and question B. So how has the number of connections changed between when we first heard about Facebook, so back in 2004, and now in 2020, or in this case 2017, according to the scale? And what might be some upside of this? And then answer question B, how do you expect the number of actual connections on Facebook compares to the number of possible connections, and explain. Okay, so take a second, mess around with this little graph, see what you can see, and we'll come back. So now that we're back and you paused it, we're actually going to be looking at these little dots here on our green chart, which is basically going to give us the scientific notation of it. So, how many people from 2004? We have, so since 2004, so 2004 for A. You can bullet point this, you can rewrite it in your own words, however you want. We had 0.5 times 10 to the power of 11 connections. And now, in 2020, we have, let me move down a little bit. We have 14, 3.38 times 10 to the power of 18 connections. Holy cow. That's a lot of connections, a lot more people. Look, it's increasing, right? It's rising. People want to use Facebook now. So let's answer question B. How do you expect the number of actual connections on Facebook compared to the number of possible connections? So let's say there's 700 users on Facebook. Do you know all 700 of those people? Most likely not, because you don't know your neighbor's mother's friend's great grandma. Like, I mean, you might, but in all reality, you guys aren't going to be Facebook friends. People you don't know, strangers, you're not Facebook friends with them. So there are more users, but oh shoot, this thing is running low on ink. But we are not all connected together. Thus, the number of connections is lower. So that means that basically we might not know everybody or the 700 people. Therefore, if our numbers are correct, our actual count of people connecting together will be lower than what a computer produces. So get ready for part 2. We have a few more things to cover.